Alright, in this video on soil fertility, we're going to focus in on nitrogen. I'll start off with the statement that more money and effort are spent on nitrogen management than any other nutrient. Why is it so important? Well, it's an essential element for plants. It's required for healthy foliage and is an integral component in things like amino acids. Plants use it for carbohydrate use, and it stimulates root growth and development. Use it in the uptake of other nutrients and plant productivity. Nitrogen deficiency can be seen in the plant as chlorosis or leaf yellowing, stunted appearance, thin, spindly stems, low protein and high sugar content, low root to shoot ratios, and plants with a nutrient deficiency in an agricultural setting will mature more quickly than healthy plants. And one diagnostic tip is that nitrogen is mobile, and so plants will translocate it from old leaves into the new leaves, so the old leaves will show the chlorosis first. Oversupplying nitrogen can also be a pretty major plant issue, as they'll take up whatever they can get, so we can see excessive vegetative growth. This can cause lodging, so this is when top-heavy plants tip over, because the above-ground portion is much larger and heavier than the below-ground portion of the plant can support. See an increased susceptibility to pests and pathogens, so a decrease in plant defenses. Can degrade crop quality in agricultural setting, and also cause a reduced flower and fruit production. So if you're growing apples or any other fruit trees, you have to be really careful about your nitrogen additions. And the nitrate buildup in foliage can negatively affect livestock. Nitrogen as a water pollutant in groundwater can harm babies, as well as in surface waters can cause large algal blooms. So nitrogen take-up, we have nitrate, which raises the soil pH, and ammonium, which lowers the soil pH. So nitrate is NO3 and has a negative charge, ammonium NH4 with a positive charge. So we'll look at the nitrogen cycle here, and this again is all going on at once, but if we are applying ammonium, then it needs to go through the two-step nitrification process to be turned into nitrate, which is then plant available, and then that enters the system. But nitrate can also be lost through denitrification up to the atmosphere. This is when nitrate is converted into N2 through reduction reactions, and then that N2 serves as a very efficient greenhouse gas. So another reason to be careful of over-applying nitrogen. So in denitrification, the nitrate ions are converted to a gaseous form through reduction reactions. This often increases under anaerobic conditions and is often carried out by bacteria under these conditions, but there are some other microbes that can do it as well. Nitrogen leaching, so nitrate is highly mobile and is sort of the form of nitrogen that's most often leached as it moves downward through the soil profile, and this is often subsurface flow, so that's our greatest loss of nitrogen. Nitrogen leaching causes three main issues. So the loss of a valuable nutrient, so by over-applying it may increase your costs, and now that nutrient becomes a waste, and so it needs to be dealt with, which also increases our costs. The leaching simulates acidification, and as we talked about in our other video, some agricultural soils are already far too acidic, and so over-applying nitrogen can just increase that issue, and then causing severe downstream water quality issues, causing algal blooms. So nitrogen fertilization, added fertilizers enter the biological cycle immediately, and if your soil food web isn't ready to assimilate that nitrogen, then we will see major losses. This is why a healthy soil food web is really important. And nitrogen fertilization should be considered as a supplement to soil nitrogen, not the sole source. So this can often result in over-application of nitrogen. So better management um, puts down soluble nitrogen that meets plant needs. So we're putting down only enough for the plant growth and at a time when the plant can use it. We also want to maintain our SOM, our soil organic matter, which can provide nitrogen naturally through nutrient cycling. And then all of this minimizes the damage from losses in the system. Again, account for the organic matter portion of nitrogen inputs in our FERT calculations, and then improve the efficiency of our fertilizer and amendments. So this gets down to that timing when plant demand is highest. It's also important to avoid oversimplistic yield growth goals. This is in agriculture, there's always their break-even point, but sometimes we need to think of our ecological impact. And then in an urban setting, with urban trees especially, it's sort of improving our knowledge to identify the lowest needed application for management goals. Understanding variability based on tree species, perhaps, in nutrient or nitrogen need, as well as timing of nitrogen applications and sort of the necessity of it. So not discounting nutrient cycling that occurs within trees.